Welcome, everybody. This is SIG Instrumentation Deep Dive. Sorry, it's intro. So I'm Piotr. I'm from Google. I'm leading SIG Instrumentation. Together with me is Frederic from Red Hat, CoreOS, I don't know, and Matthias from Ludzi. So this will be a high-level overview of what SIG Instrumentation is doing, what is this SIG about, what are the problems that we are trying to solve. Later this week, on Friday, we have a deep dive session where we'll, let's say, look into the components that we own and see how do they work internally. So this is on Friday. Okay. So what is our mission as a SIG? So it's this is a quote from our proposal when we created this SIG. It covers best practices for cluster observability through metrics, logging, and events across all Kubernetes components and development of relevant components. We also coordinate metric requirements of different SIGs for other components through finding common APIs. So basically, this is metrics, logs, events, and best practices for monitoring in general. What is our charter? So the first thing that we own as a SIG in open source Kubernetes community is Core Metrics pipeline. So this is the pipeline that is included in Kubernetes out of the box, which provides you the very basic resource usage monitoring like CPU, memory, disk usage. We also own Core Logs pipeline. Again, this is what is included in Kubernetes out of the box, and this is kubectl logs, which displays logs like the recent logs from your containers from its stdr and std out. We are also responsible for instrumenting all system components. I mean, exposing metrics from system components and in a way that this is consumable by monitoring systems. In addition to this, we have some monitoring extensions that doesn't, let's say, which are not critical for Kubernetes use, but they are very useful. This is, for example, kube state metrics or custom metrics API adapters, which allows you to integrate Kubernetes with third-party monitoring solution. And the last piece of what we are doing is integration with third-party monitoring solutions. Like, we don't own this integration, but what we do is we give you best practices around this and making sure that it's happening, basically. So Core Metrics pipeline consists of kubectl top, which is a command in kubectl tool, master metrics API, which is official Kubernetes API for exposing resource usage metrics. There is also metric server, which implements this API. Kubelet summary API is an API exposed by Kubelet that provides the data for the pipeline, that collects the data for the pipeline. This is shared responsibility with SIG-Node. And in addition to this, there is C-Advisor underneath, which collects those data and make them very available through Kubelet summary API. And again, this is shared with SIG-Node. So core logging pipeline, again, kubectl logs command. There is a way of exposing logs from Node, which is through some HTTP handlers exposed through Kubelet. In addition to this, there is log retention and rotation policy, so making sure that your logs basically are deleted after some period of time so that you will not use the whole capacity from a machine. And there is the way how we handle logs in CRI, Container Runtime Interface. There is a lot of overlap with SIG node, so we are working with them. Monitoring extensions, as I mentioned, this is Kubestate Metrics, a really useful tool that is not needed for Kubernetes to operate, but it gives you a lot of information about what's going on with your cluster state. We'll dig into the details later. Custom Metrics API, this is a Kubernetes API, well-defined API that allows you to plug in your third-party monitoring solution with Kubernetes so that Kubernetes components can consume metrics from outside world, basically. There is also Custom Metrics API adapters, which are an implementations of this particular API. It's basically not fully owned by the SIG. It's rather that the model is that third-party monitoring vendor provides such adapter, and we as a SIG are helping them to basically integrate. And there is Hipster component, which is the central monitoring component and central integration points for the other monitoring storages, and it's about to be deprecated. And we'll talk about this during the deep dive. And the last piece of our responsibilities is this integration with third-party monitoring solution. So we are giving best practices and guidelines how to do this. There are some reference integrations. So for example, when we develop Custom Metrics API, we also develop the implementation of this API for Prometheus. It was not because Prometheus is the monitoring solution that we own, but we rather wanted to have a proof of concept that it basically works end to end. We are also responsible for the way how those third-party monitoring vendors can consume metadata. So that in addition to metrics, in order to make them useful, you need some metadata like deployment name, pod name, namespace, and many other Kubernetes specific metadata. So this is something that we care about. Okay, so here are the leads of our SIG. So there is Frederic, myself, and Fabian, who was co-founder of this SIG, but in the end of 2017, he decided to basically delegate this responsibility to Frederic, and he's now emeritus. We have biweekly meetings every second Thursday at 5:30 UTC. So this is early in the morning, US time, and in the afternoon of Warsaw time. But it's hard to find something better, unfortunately. So what we did in 2017, we introduced this Core Metrics pipeline. This means that we defined this Core Metrics API, which is now in beta. In addition to this, we provided Metrics Server, which is the default implementation of Core Metrics pipeline. Metrics Server should be deployed to all Kubernetes cluster, basically, especially those who want to rely on kubectl top or horizontal pod autoscaler functionality. In addition to this, we developed a few monitoring extensions in 2017. We defined Custom Metrics API in beta. The primary consumer of this API is horizontal pod autoscaler, which uses those metrics for scaling your workloads based on basically any arbitrary metric like QPS or length of your pub/sub queue, whatever. There were also two implementations of this API developed. in 2017, one for Prometheus, one for Stackdriver. I'm looking for more. I would like to have more. But it's basically business of third-party monitoring vendors. We also graduated KubeState metrics to GA, which means that this is stable and production-ready component right now. Yeah, we'll talk about this later, like what it actually does. Our plans for 2018 is around stabilization. So everything basically that we introduce, we would like to go to GA with this. So those two APIs. Metric server is now under incubator. We want to graduate metric server from incubator and deprecate hipster finally. We have also some plans on introducing new concepts to the monitoring area. One is historical metrics API, which could be used by vertical pod autoscaler, and the other Kubernetes components that require access to historical data. Metric server provides only access to the most recent resource usage data. There is no good story on how to consume metadata. There is a few options. One is to query Kubernetes API server directly. There is also this unofficial /pods handler in kubelet, exposed by every kubelet, and some of the monitoring vendors use this one. There is also an option to rely on some environmental variables that are set, like this downward API. Logs are handled in a way that the logging path contains basically metadata there, at least some subset of metadata that are crucial to understand to which pod those logs are actually belongs to. And we would like to standardize around this. We would like to provide an official guideline on how to integrate with Kubernetes. The third idea that is in our mind is how to handle logs from files. As for now, by default, we handle only logs coming from std out. This is okay. This works for many users. At the same time, this is not enough for all those legacy applications, Java applications, for example, which by design logs to different files. Okay, and I'm passing the mic to Frederic.
So now that Piotr explained basically how some of the components that we own, at least some of those I want to explain in a high-level overview of how they actually work. So in this particular example, we're basically looking at how kubectl top would utilize the resource metrics API. So kubectl top would request the Kubernetes API, and the resource metrics API is actually an aggregated API. And what that means in Kubernetes is that you start that specific server, so the metrics server, for example, but really any implementation of that API, and then you register it at the API server. And then the API server knows that for this particular API, the core or resource metrics API, I will forward all of these requests to the metrics server. And then that particular instance will reply to that response. And that's basically the path of the request. And the implementation of the resource metrics API somehow needs to gather all of this information from the respective Kubernetes nodes. And so, as Piotr already mentioned, the metrics server is the canonical default implementation for this. And really what the metrics server does is it, in a 1-minute interval, just goes through all of the nodes in your Kubernetes cluster, gets all of the metrics from that node, as well as all the pods running on that node, and just stores it in memory, and whenever you do a request, it returns that. And we did some benchmarking, and it does fulfill all of the scalability requirements that Kubernetes has. So 5,000 nodes and an average of I think 30 or 50 pods per node. And something that we have been working on over the past year and a half, around a year and a half ago, we specified all of these APIs. So we actually had to then start migrating all of the components within Kubernetes that were previously using Heapster to actually use these metrics APIs, so that we can finally now deprecate Heapster a year and a half after we started this effort, because that's basically what we were going for, that Heapster had become a problem, and we'll explain more in the deep dive about this. But finally, with Kubernetes 1.10, we've arrived at a point where the last bit has been migrated, which was kubectl top, to use the resource metrics API. It's not particularly spectacular, but finally this is the last piece that was necessary to be migrated. And as Piotr already mentioned, it just gives you metrics about pods and containers and nodes, and just very basic metrics, so CPU and memory. And respective to their Kubernetes API object, so the pod is namespaced, while the node is not. So that's important for RBAC, for example, so that you can control who actually gets to view these kinds of metrics. And very similar, this kind of thing works with logs, except that that's not an aggregated API, because the logs are local to the nodes, to the kubelet. So whenever you do a kubectl logs my pod, and you want to view that particular log, then you do a request to the Kubernetes API, and that's the sub-resource logs or log of pods, of the pod resource. And when you do that, the Kubernetes API server figures out on which node that particular pod is scheduled onto, and then does a request to that kubelet, which is then the node logs API on the kubelet API. And the kubelet really just basically reads that log file and just sends it back. And if you tail, then all of this is a WebSocket basically, and all of this information is then transferred to your client. And just so everybody knows, the default for log rotation here is 10 megabytes. And when this actually kicks in, and you list the logs, that will be empty, because kubectl logs always only gives you the latest rotation of the logs, basically. And I'm not exactly sure what the default retention is. Maybe 5 rotations. Okay. So events are also something that falls under our responsibility, but events might be handled in a bit different way than you may be used to in other systems. So this is not an event as in, it could be handled like that, but by default in Kubernetes, it's not handled like a log line. So sometimes when we log something, we say that's an event, but it's not the equivalent in Kubernetes. In Kubernetes, events are actually stored in etcd, and etcd is not like Elastic or something where you want to store many events over time. It's very limited in that regard, and that's why we try to keep the amount of events a particular component can expose low, and it's actually updatable. So when you list your events for an object, for example, if a pod can be scheduled, then it will always update that for the last time it's seen that, for example, and update the description of events, possibly. Now this can possibly create a lot of traffic on your etcd, and So if you're running really, really high scale clusters, this can really put a lot of churn on your etcd cluster. So I recommend having a separate etcd cluster if that's the case for you. Now moving on to Prometheus support. So all the Kubernetes components themselves actually expose Prometheus-style metrics. And basically what the data model of Prometheus is that you have a set of labels where the name of the metric is actually, it's actually also labels. It's just a meta label basically that internally gets converted, but it's the exact same thing as any other label internally. And then you have the combination of all unique label combinations, or one unique combination identifies a time series. And then you have a value associated to that time series, and that's something you could query. So for example, what you could do is you could just list all the time series that have the code 200, for example, or more likely is that you will want to see all the time series with the HTTP requests total, but you can slice and dice this in any way that you want, and then do aggregation over that, for example. And the primitives of metrics that are available in the Prometheus format are counters, gauges, histograms, and summaries. And yeah, basically, depending on the type of information that you want to expose, these are the options that you have. So this is actually what it looks like when your application exposes Prometheus-style metrics. So you have your metric name, as I mentioned, and then in the curly brackets, you basically specify all the extra labels that you want to be associated with this particular time series, and then the value for that. And if you would want to instrument your own application with that, then you could do that in either one of the officially supported languages, but there are also a ton of community-supported ones that are just as good. And typically, the way that you instrument your application is that you create a Prometheus registry. This is a Go example for just to demonstrate. You have a registry and you register a metric, for example, the request counter here, and then through the life cycle of your project, of your program, you, for example, could use request counter with labels, and you set the label values and increase it. This is what would be an example for a counter metric. And that's how all the Kubernetes components are instrumented. So whenever you go to any of those components, they will have things like requests total, request latencies. And this is really important because it means that we can treat Kubernetes components as a whole as opposed to individual components, and that just makes monitoring this system much more easy. And all of these components also use the Prometheus standard, which is just exposing the metrics on the /metrics endpoint. It's just an HTTP server that every Kubernetes component has anyways, and exposes that in the text format I just showed. So this is a more elaborate example of what this could look like. In this example, we have Go metrics from the Go runtime. So you could see things like if you have a memory leak or something like that, or Go routines that you haven't properly stopped or that haven't ended, or something like that. So it's very useful to do this. And there were actually multiple things in Kubernetes that we've discovered because of these metrics. So for example, in Kubernetes 1.8, we had a pretty big memory leak, ironically, because there was a leak in how metrics were registered. But we discovered it through metrics as well. So I guess that cancels it out. But it's really useful for these kinds of things, and that was obviously not the only time we caught something with metrics, but it's an ironic example that I like to tell. Here's just some to show that we actually use this in the Kubernetes project, in the autoscaler, for example. So also the autoscaler, which uses metrics to autoscale, has metrics itself.
Maybe let's keep cube state metrics because we are out of the time. So let's.
Are we? Okay.
Fast forward to demo.
Yeah, I mean we can.
We'll cover this
in the deep dive, right? Yeah. All right. So can you maybe? All right. So we are back to some demo moments. Yeah. So first of all, I want to show you the repository. So this is the metric server. It's still in the incubator, as previously mentioned. So in the Google container Kubernetes engine, it's already deployed, so you don't have to do anything. If you want to deploy it, just go to the deploy folder and pick the version, do a kube control apply, and then the metric server is up and running. So what you can do with that is you can do like a kube control nodes, and it will tell you the utilization of your cluster or like the individual nodes. You can also do a top, and then I will just print all namespaces for this demo. So we'll see the CPU utilization and the memory utilization of each pod in the cluster. Yeah, I mean, you can use that for your requests and so on in your definitions. Then we have something called kube control logs, as previously mentioned. So you can do something like log the Prometheus operator right here. So we get all these logs. Something really nice about this is if the pod crashes, we can do a -p for previous. So, I mean, it didn't crash. Kudos to you. But then we would get the logs from the previous pod, even though it isn't running anymore. For the kube control get events, we can simply show the events that are happening in the namespace. So this is by default the default namespace, so we can see what's going on there. And we can also watch that. And yeah, we also have a severity, so we can filter by severity, like how important these errors or events basically are in the cluster. Yeah, so onto the kube state metrics. So kube state metrics, yeah, can take it for a bit. So kube state metrics is something like a wrapper around all the Kubernetes objects that aren't already exported by the master components themselves. So we have this project which exports like the creation time of all the objects or different kinds of yeah, metadata and so on for these Kubernetes objects. So you can find a list of all the objects that are available with metrics in the documentation. So basically everything outside of custom resource definitions. And I just quickly want to show you how it looks like when you query the metrics endpoint for kube state metrics. So I mean, it's just a really long text file that you get back with the yeah, different kinds of metrics for all those objects. You can do pretty yeah, interesting or like important things on that. So in this case, I can show you the cluster that is running. We have in the default namespace some pods that are in a crash loop backoff, so they are just like restarting every time. And then we also have a pod that isn't able to schedule because of a wrong configured pod affinity. And yeah, due to all these kube state metrics that we expose, Prometheus can alert on that. The Prometheus operator has a bunch of really good examples for alerting rules. Yeah, so you can go in here and say, see that those pods are actually crashing all the time. And also there is the crash looping. So it will show you that like one of your applications is going crazy in the middle of the night. Additionally, there are also dashboards for all these metrics, and you can really dive deep into what is going on in your cluster, so you can see like which namespace is utilizing your cluster more, and you can drill that down to per namespace, per pod, per node, so you get like the whole idea of what's going on in your cluster, and that's all due to the work of the kubestate metrics and the SIG Instrumentation projects. So I guess with that, questions?
Can we switch to slides?
Yeah.
Can I just ask, where can I find the dashboards, Grafana dashboards you just showed?
So we'll cover this during deep dive on Friday. The idea is that Kubernetes is not about monitoring. A part of, let's say, what is coming out of the box is very bare minimum that you need, which is kubectl top, kubectl logs, kubectl get events, resource metrics API, which allows you to consume those metrics in pragmatic way, programmatic way. So this is okay if you have very basic use case, but it's not enough for production ready system. In addition to what is included in vanilla Kubernetes, you need third-party monitoring solution. And we'll show an example of this is Prometheus. We'll show how can you integrate Prometheus with Kubernetes easy on Friday.
Concretely, the dashboards are in the Kubernetes-monitoring/Kubernetes mixins repository. There's a really awesome talk tomorrow or Friday by Tom Wilkie covering this topic in like very deeply just about dashboards. So I recommend going there. Any other questions?
Thank you. So this is a sort of an open-ended question, and I don't expect a full answer because, again, it's really, really open-ended. But my concern is that there's now basically 3 different things exposing Prometheus metrics with some overlap. So in this case, API server, metrics server, and kubestate metrics. And again, they all overlap in some way. In some sense, and also the metrics that they expose, it changes like the list of metrics, and I realize that's sort of not versioned, so there's no versioning to it. You just kind of expect the metrics to be there, but depending on what Kubernetes version you use, it might be there, might not be there, etc. So my concern is that now you basically have 3 different points of sources of truth for metrics. So what's the idea there? What's the direction?
So maybe I will answer what is the motivation behind having all those parts, and maybe Frederic can address the other part of the question about versioning. So from API server, you expect to have exposed metrics about internal state of API server. How many requests are coming, how many of them succeed, what are the HTTP response codes, and so on. No metrics about the Kubernetes cluster state itself. Then for resource metrics API, this is an API Kubernetes quality, Kubernetes standard API that expose resource usage metrics about the recent the latest resource usage metrics about containers running in your cluster. And the primary goal for having this API is to have those metrics consumed by other Kubernetes components like horizontal pod autoscaler, kubectl top, scheduler in the future to make better scheduling decisions. And this is not that, like, by design, this is a part of Kubernetes API so that they can be easily consumed from Kubernetes and doesn't require to have integration with third-party monitoring solution. Kubestate metrics is a tool designed to basically expose metrics to other systems like Prometheus so that you can alert based on the cluster state.
Yeah, particularly for kubestate metrics, we take extra care not to break any of those, and we haven't since 1.0 at least. Before 1.0 we did. But for after 1.0 we haven't. The problem is within the Kubernetes project as a whole, we can't oversee every single change. So if there is a breaking change, then do make us aware of that so that we can try to not, try to revert that in patch releases of that particular Kubernetes release. Of course, if a component disappears, there's no reason to keep the metrics, but we should be doing a better job of that, particularly with cAdvisor. We're thinking of ways how to replace cAdvisor in that stack to have more consistent and more stable metrics. But that's still a very early discussion, but that discussion is happening because cAdvisor has broken pretty much in every point release of Kubernetes so far. So that's not a situation that we want. So that's what we're trying to improve. And there has also been the discussion. I don't think there is any implementation, but to basically have a resource metrics API based on Prometheus metrics, because at the same the metrics server and Prometheus are still basically scraping the same data, where Prometheus scrapes cAdvisor and the metrics server scrapes the kubelet APIs, but essentially it's the same data. So there might be a Prometheus-based metrics server at some point. But for sure, the metrics server itself will stay and will always be the canonical implementation, because that's something that you can deploy independently and don't need to rely on a monitoring system like Prometheus. So we definitely want the unopinionated way to offer that, but for sure there should be a way to not duplicate those resources. Sorry for talking so long.
We are out of the time, so thank you very much. If you have more questions, there is one more question, come to us and we'll handle them offline. Thank you.